Okay, so as we said in our last video, our ideal strategy for estimating the effect of education on earnings would be to randomly assign some people to receive higher levels of education than others. In other words, we would flip a coin. Anyone who got heads would have to stay in school for an extra year. Everyone who got tails would have to leave school. Then, if we compare the earnings of people who got heads to the people who got tails later in life, we would be confident in saying that any differences we saw were a result of differences in education, because nothing about the individuals with heads and the individuals with tails should have differed before that coin was flipped, right? The coin toss has nothing to do with you as an individual, and because that coin toss shouldn't have affected you in any way other than affecting your level of education. Now, Angrist and Kruger aren't able to do this. They don't do a real experiment, but they claim that they've found a natural experiment. That is to say, a reason that people get more or less education that's effectively random from the perspective of the person and unrelated to anything else that would affect that person's earnings. The way that they do this is they take advantage of the features of the Vietnam War draft. So during the Vietnam War, in 1969, the government implemented a drafting procedure where first they assign everyone a draft number at random, and then when they decide how many people they need to draft, they call up all the numbers from 1 up until some threshold. So for example, if they called numbers 1 to 100, if you were draft number 90, you would be drafted. If you were draft number 101, you would avoid the draft. Now, the reason that this is going to be related to education is that not everybody with numbers 1 to 100 would have to go. In particular, you could avoid service if you fell into a set of categories. So for example, if you're a conscientious objector, if you were medically unfit, if you were working in an essential occupation, or, and this is what's going to be relevant for our purposes, if you were currently a student. And so as a result of this, if you expected to get drafted, if you thought that you had a high risk of being drafted, that would give you an incentive to try to stay in school longer in order to be ineligible for the draft. So the basic idea here is, you're given this number at random. The lower your number is, the more at risk of the draft you are, and the more at risk of the draft you are, the more likely you are to stay in school. So this is as close as we're likely to get in the real world to flipping a coin and using that coin toss to decide whether we need to keep you in school for an extra year. And we might have some hope that this experiment is going to work, that this natural experiment can tell us something about the effect of education on earnings, because we see that during the Vietnam draft period, from about 1964 to when the draft was ended in 1973, there was a peak in male college enrollments, which many people have attributed to the Vietnam War. In other words, it looks like there's some evidence that men did go to college at higher rates than they would otherwise to avoid the war. And if this is true, this gives us some hope that your likelihood of being drafted is going to be associated with your likelihood of going to college. However, having your draft number affect your likelihood of going to college is just one of several things we need to be able to treat your draft number the same way we would treat a coin toss in the experiment. So if the first thing we need is that your draft number does tell us something about your likelihood of going to college, the other thing we need is that your draft number isn't related to your earnings in any other way. And in particular, we can think of this as having two components. The first being that the draft number is random relative to your characteristics. In other words, that people with higher ability aren't going to have higher or lower draft numbers than people with lower ability. And the second thing being that the draft number isn't going to have any effect on you in your life and your earnings other than through its effect on your education. So the first part of this, number 2 on this list, is really straightforward. If we think about what the argument is for why we can treat the draft number as random with respect to your personal characteristics, that's the whole point of the draft number, right? The way these draft numbers were selected is that the government drew birth dates out of an urn on national television and associated each birth date with a draft number. So the only reason that we would see non-randomness in the draft number relative to your adult earnings is if people who were born on July 27th just so happened to be different from people who were born on July 28th. The other part of this, though, that the draft number doesn't affect your life other than through its effect on your education, is going to be a much, much harder assumption to buy. What this means is essentially that thinking that you're more likely to get drafted isn't going to affect your earnings other than through pushing you into college. Now, there's one huge problem with this, right, that Angrist and Kruger spend most of the paper addressing. So, number 3, the huge problem is, of course, military service. Right? The more likely you are to get drafted, the more likely you are to get drafted. If you had a low draft number, you're more likely to end up spending time serving in the military, and spending time serving in the military is likely to affect your earnings. And in fact, Angrist and Kruger find in earlier work that your likelihood of getting drafted, that the more likely you are to get drafted, the lower your adult earnings are. In other words, spending some time in Vietnam is pretty damaging to your long-term earnings. So how are they going to deal with this problem? Well, the simplest thing to do, and the most straightforward thing to do, would be to say everybody who had a draft number up until the threshold gets drafted. Everyone with a draft number above that threshold thought they might have been drafted but avoided the draft. In other words, if you have numbers 0 through 100, 0 to 300, and they draft up to number 100, right? People 0 to 100 go to Vietnam. If they're not in school. Numbers 101 to 300 aren't drafted. But number 101 thought they had a very good chance of getting drafted, right? They were almost drafted. So they're likely to try to stay in school to avoid the draft, whereas number 300 likely thought that they were safe. So this strategy would work, and this does form the basis of what they try to do, but it's not going to be perfect, because one of the ways that people tended to avoid the draft was by volunteering preemptively for service. And the idea of this was essentially that if you volunteered for service, you'd have more control over the conditions under which you served. So you might be able to volunteer for a different branch of the military, the one that's going to give you the safest conditions. You could also potentially put yourself in the National Guard or some other set of units that were less likely to see service. So as a result, number 101 might actually have a higher likelihood of going to war than number 300 would, as well as having a higher likelihood of going to college than number 300 would. So the way that they eventually deal with this is they take a couple different approaches to this. The main thing they do is they say, we're going to use our draft number to predict your likelihood of going to college. We're also going to use it to predict your likelihood of serving as a veteran. But because of the fact that the relationship between these two things is different, in other words, being just above the threshold but close to the threshold is going to be similar in terms of college attendance to being just below the threshold but close to the threshold, but will be very different in terms of military service, they'll be able to disentangle these. They'll also do the simpler thing of just directly controlling for military service. And then the final thing they'll do is they'll say, let's imagine we're wrong about the effective military service. Would changing the estimated effective military service on your earnings have a big effect on our conclusions about education? So this is going to be the main problem and the thing they spend most of their time dealing with. But there's also smaller problems, right? As we said, you could avoid military service, not just by going to college, but also by being a conscientious objector, excuse me, by working in a strategically important industry. And of course, you could avoid military service by doing something like fleeing to Canada or intentionally injuring yourself. And all of these things could potentially affect your earnings as well. Angrist and Kruger essentially say, let's not worry about that stuff, because if we look at your likelihood, if we look at the number of deferments given for various reasons, educational deferments are just so much larger than all that other stuff that we can essentially round it down to 0. So as a result, they say we're really only going to worry about these two effects of your draft number, your military service and your education level. And we're going to be able to separate these things from each other because of the fact that your education level is going to depend on your draft number in a way that's fairly different from the way your military service depends on your education level, on your draft number. Okay, so let's say that we completely believe Angrist and Kruger that we can treat your draft number as a natural experiment. In other words, we believe them that the only way that your draft number affects your earnings is through changing your education or changing your military service, and we're able to distinguish between the effect of education and the effect on military service, right, by using things like threshold values of our draft numbers. In this case, this brings up the question of how we can use that information in order to determine the effect of education on earnings. So if we were going to think about this as a difference in difference or as an experiment, what we would want to do, right, is separate people into two groups. So we would have the draftables. We would have the undraftables. Right, so low numbers and high numbers. And in an experiment, we would just compare the earnings of the draftables to the earnings of the undraftables, and we would then attribute whatever changes we saw between these two groups, whatever differences we saw between these two groups, to the effect of education, right? If we did this as a difference in difference, we would say, let's compare the change in draftables to the change in undraftables over time. But in both cases, what we would do is we would have a treatment group, we would have a control group, we would compare their averages. But in this case, we don't have a clean separation between people with low numbers and people with high numbers, right? If I'm number 50 and you're number 51, I feel like I've got a slightly higher chance of being drafted than you do. If you're number 100 and I'm number 101, exactly the same thing. So we might expect that your likelihood of getting educated or of staying in school is increasing every time we reduce your draft number, right? So anytime we wanted to grab people and lump them into one box or the other, we would be throwing away a lot of useful information. In other words, instead of having two groups like this, right, we have a whole spectrum ranging from 0 to 300. And as we go in this direction, we're less likely to get drafted. And thus less educated. So what this means is we need some way to use this continuous information, right, this full relationship between draft number and your level of education to estimate the effect of education, right? We want some way to, instead of separating people in a treatment group and a control group, have your treatment status be a continuous function of your draft number. So the tool we've used to try to estimate continuous relationships like that is linear regression, right? So what we can do is we can say, if I want to be able to guess at how much education you got on the basis of your draft number, I could do something like education I equals, let's say, gamma 0 plus gamma 1 times draft number plus an error term, right? And what this is going to do is it's going to tell me, if I know your draft number, what's my best guess about how much education you received? And so what we'll expect, right, is that gamma 1 is going to be less than 0. In other words, the lower your draft number is, the more likely you are to stay in school. And how much education we expect you to receive, our guess at your education, we can call ed I hat, and that's just going to equal this piece here, right, which is our guess. Gamma naught plus gamma 1 times your draft number. Okay, so where this leaves us, right, is we can say, based on your draft number, we know how much education we expect you to receive. That also tells us we have some guess about your education that should be, from the perspective of your earnings, as good as random. So if we then said, let's do a regression of our earnings onto our expected level of education, we could treat this expected level of education as basically equivalent to education induced by a coin toss, right? In other words, we're not going to need to worry that your expected level of education is higher if you're higher ability, or higher if your family is wealthier, or higher if you're in better health, or all of these other things. This is just higher because of the piece of paper the government picked out with your birth date on it, right? So as a result, our beta 1 here should measure the real effect of education on earnings. Right? Because the way that our guess at your earnings changes, if we know that you had a slightly higher level of education due to the draft, is going to depend just on the effect of that draft on your earnings, which we've asserted is just because of the effect of the draft on your level of education. Okay, another way to think about this is that this regression here, right, is equivalent to saying earnings equals beta naught plus beta 1 times gamma naught plus gamma 1 times draft number. Right? Right, this is just what education hat is. Which means that this is equivalent to just running a regression of your earnings on your draft number. So if we'd run this initial regression, right, ed equals gamma naught plus gamma 1 draft number, and then we'd also run earnings equals, let's say, sigma naught plus sigma 1 times your draft number, right? We could basically say that this sigma would equal beta 1 times gamma naught. So beta 1 is going to equal sigma 1 over, times gamma 1, sigma 1 over gamma 1. In other words, the effect of your number on earnings over the effect of your number on education. So just to back up for a minute and think about what this is telling us. What this is telling us is, because of the fact that this sigma 1 should only reflect, the relationship between draft number and earnings should only reflect the fact that people with lower draft numbers have higher levels of education. This sigma 1 tells you, how does having a higher draft number affect how much we expect you to earn? The gamma 1 tells you, how is a higher draft number going to affect the amount of education you get? Because sigma 1 is just the effect of education, this is telling us what's the effect of a draft number per the effect on education, right? And that's going to tell us the effect of education on earnings. So this is equivalent to, if we did a real experiment, right, instead of our draft number here, we would have the coin toss, right? We would have whether you got heads or tails. We would be saying the effect of getting heads on your earnings is just going to be a result of your education. And we would then calibrate by saying how much more education do people who got heads get versus people who got tails. Okay, so I'm not super concerned about whether you understand all of the details of that regression, of this instrumental variables regression strategy mechanically, but it is really important to me that you understand the strategy behind this. In other words, the idea behind it and what we need to assume for this. So I just want to lay this out again, but just thinking about the gist, right? Just thinking about what's crucial here. So the idea here is our draft number is what we're going to call an instrument. And what it means for it to be an instrument is that it's related to education, but it's not related to earnings. Or rather, it's only related to earnings because it's related to education. And as a result of that, right, if the instrument is related to outcome, the relationship between our draft number and our earnings has to be due to the relationship between education and earnings. In other words, whereas if we just looked at the raw relationship, right, between level of education and earnings, we would include in that all of the ways that we would guess you'd have higher earnings because people with higher levels of education are different from people with lower levels of education. The relationship between your draft number of your earnings and your earnings can only be a result of the ways in which higher levels of education cause differences in earnings, right? Because of the fact that people with high and low draft numbers are otherwise identical. And the last thing is, we can get the relationship between education and earnings from the relationship between draft number and earnings by taking the ratio of the relationship between draft number and earnings and the relationship between draft number and education. So we can think of this as change in earnings from a change in education is going to equal, right, change in earnings from a change in draft number over the change in education from a change in draft number. Right? We're going to get this by regressing earnings on draft number and this by regressing education on draft number. And the last thing I want to say here is that just like in a difference in difference, the method here is really only as good as its assumptions, right? So we can't just grab any old thing and call it an instrument and do an instrumental variables regression and think we've accomplished anything. We're only going to be effective at using this strategy if this assumption holds, right? If we find something that really counts as a natural experiment, that really only affects our outcome through its effect on our independent variable of interest. Now, the way to think about this, right, really big picture is, when we try to get to a causal relationship through controls, what we're doing is we're taking away all of the variation in our independent variable, right, all of the variation in education that isn't, that could be a source of bias, right? Every part of our relationship between earnings and education that comes from the fact that educated people are just different from less educated people in a way that affects earnings. And our hope is once we've controlled for everything that causes bias, all that's left are differences between more and less educated people that aren't related to earnings. With an instrumental variable strategy, we go about this the opposite way. We say, let's identify some source of variation in education that isn't related to earnings, and then see how that source of variation is correlated to earnings, right? And because that source of variation isn't related to earnings, other than through its effect on education, that relationship must measure the effect of education on earnings.